All right, hey friends, we're just going to work with some more information. We need to use the thing that's called included. Included means between when you talk about it in geometry. All right, so when you think included, think between. All right, so when we talk about this, we have an included angle. All right, an included angle is an angle formed by two adjacent sides of a polygon. And what do I mean by this is look here at the example. We know that angle B is formed by segment AB and segment BC. So angle B is the included angle between sides segment AB and segment BC. So that means included. You know, the same idea though would happen for angle A. Angle A is included between segment AB and segment AC. So it's an easy way of keeping track of them. So AB and AC include this angle. But we can also do the same thing. We can have an included side. An included side is the line segment I would always say shared or between two consecutive, and that's not looking very well, it's an N here, consecutive angles. So for instance, let me give you an example here. Segment AC is the included side for angles A and angle C. So it helps us go in between. So AC is between those two angles. So we can have it included. And the reason why we have it included is because it helps us with location when we work with these. Also don't forget opposite sides. Angle B is opposite segment AC. AC and B are the ones that don't touch. A is opposite segment BC and C is opposite AB. That's just a side notation of stuff that we need to know. Then we're going to do our last postulate today, and today it's the side angle side congruence. Now, how many pairs of congruent sides do you think we're going to have? 2. How many pairs of congruent angles? 1. And where do you think those angles have to be included? That's right. They have to be included. So that angle is included. It's between the two sides. So let's write this theorem down. If two sides of one triangle and the included angle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So what do we mean by this? Look at the diagram here with the hypothesis. If I can show two pairs of congruent sides, so I have a side and a side here, and I know the angles in between are congruent, I have what's called SAS, basically, side, angle, side. I know that the two triangles are going to be the same with each other. And the idea is, if I use the same measure of the angle, let's put it right here. I'm going to do a quick diagram. It's a 45-degree angle real quick. And if I do another 45-degree angle, I'm trying to do this about as good as I can get it without being the same. Okay, So these are both 45 degrees, okay? Now, if I use the same side links, let's use our paper clips again, and they're the same, if I put them together so they're touching, I know the other end points are going to be, if this will quit moving for me, right here and here. So that side is formed right there. So I know these two are going to be the same. Now notice here again, I'm going to do the exact same thing. I'm going to do the touching here, and we're going to put our two sides together. Again, I know these two segments are the same length because they work with it. Now, because I freehanded, this might not be exact, but I got close to about 1 inch. What did I get here? 1 inch. I know those third sides end up being congruent. So basically, if I use the same angle in between, I know these two triangles will end up being exactly the same size. That's the SAS congruence. Now, the letters side, angle, side are written in that order because the congruent angles must be between the pairs of corresponding sides. Side, angle, side, SAS congruence. It's huge that we be able to work with that. Now, here's an example of why this works. It says, the diagram shows the part of the support structure for a tower. Use SAS to explain why triangle XYZ are congruent. Well, what do I know first? Segment XZ is congruent to segment VZ because it's given. That gives me a pair of sides. Then I'm going to actually look at my vertical angles. Because I have two intersecting sides, I have a pair of vertical angles, and by the vertical angle theorem, they're congruent. So I know angle XZY is congruent to angle VZW. And that's the vertical angle theorem, right? And that gives me a pair of congruent angles. And then our last but not least, I use line segments here. I got segment YZ is congruent to segment WZ because they're also given. But that gives me another pair of sides. Is the angle, and look at side, angle, side, between the two sides, is it included? Yes, it is. Well, therefore, the two triangles are congruent. So this is how we would explain it more than just the physical one. I'd go triangle XYZ is congruent to triangle VWZ because two pairs of congruent sides and the included angles are congruent. By the vertical angle theorem. So side, angle, side congruence works. So it lets us kind of know how they're put together. All right, we're going to go into the